Hello, 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 Kevin here, and I'm taking a break this week from the Kerbal Space Programming series that I've been making because I want to do kind of a deep dive talking about one of the features that is coming out with kOS version 0.19.0, specifically function delegates, because I think that this is going to really be a game changer in terms of designing fantastic programs in kOS for Kerbal Space Program. So what I want to talk about today is what are function delegates and how can we use them? What are some of the cool things that we can look forward to doing in our programs with this next release? So we've had user-defined functions for a while. So I can define a function foo, and I can say what it should do. I'll say print foo, and that's all it does. And I'm just going to go ahead and call that function. Now I have a ship sitting on the launch pad, and I've set up my editor so that it will go ahead and copy this over and then run it. So I'm just going to hit a hotkey, and it's going to take a second, and it's going to go run. It's going to go, okay, it prints foo, and then the program ends, and I can go ahead and hit enter and go back there. So we've seen now we can define our functions. It can do stuff. This is wonderful. Let's go ahead and make our function actually do something, though. We'll say it takes parameters, takes parameter A and B, and it's going to return A plus B. Right, so it's a very, very simple function. And of course, if we run this now, we're going to have an issue. Yep, the number of arguments didn't match the number of parameters. It's expecting 2 arguments. We'll go ahead and do that. And let's actually print the result of that. And if we go ahead and run this time, there we go. We get the answer of 5. Now, of course, this is an adder, right? So let's go ahead and say set adder to foo. All right, so let's say we've got this function, we've made it, we want to set it to another variable just to make it a little easier for us to remember rather than renaming the function directly. Now the problem is if we go ahead and try to do this, traditionally we run into a bit of an issue. We run into that same number of arguments error that we saw before, and the reason for this is that whenever we reference this function, even if we don't put these parentheses here, we are trying to execute the value of that function. If we were to set adder to foo23, well then we would know what would be assigned. Adder would be set to 5. It's not going to be set to the function itself, it's going to be set to the result of calling that function. And even when we don't have these parentheses, it's going to try and call that function. What function delegates allow us to do is by adding this @ sign at the very end, we can now refer to the function as a regular variable. And we can go ahead and assign it. So now I can say print adder 3 or 4 or 5. And if I run this, we get the value of 9. So now this seems like a very minor improvement, but the reality is that this provides some incredible benefits, and I want to talk about what that is. So it doesn't make a lot of sense for us to leave this called foo. So I'm going to go ahead and call this adder, and we can go ahead, there we go, we've got adder, and we've got that. Now, one of the things that we can actually do here is rather than taking 2 arguments, I'm going to sort of change this up. I'm actually not going to call this adder at all. I'm going to call this, I'm going to call this make adder. I'm going to call that function make adder, and it's only going to take 1 parameter. It's going to take parameter A, and we're going to put a function in here called adder, and this is going to take parameter B, and it is going to return A plus B. And then down here what I'm going to return is I'm going to return the function delegate for adder. So now what make adder is going to do is it's going to take 1 argument and it's going to create a new function that takes a 2nd argument, and then it's going to return the values that were passed in to both of these. So what I can do now is I can say set adder to make adder 5, and I can say print adder 6. And if I go ahead and run this, here we go, that's 11. We got our value. So you see what's happening here is we're actually calling a function that returns its own function. And we could actually change the syntax by which we call this. We could run this exactly like this. Actually, we don't even need the set then. We can just print, delete to start of line, print, whoops, nope, come on, print that. And there we go, we get the same value. So this is, now what we're doing is we're evaluating these arguments separately, and this is called partial application. It's a thing from functional programming that's kind of cool. What we can instead do is, now that we've got this, we can say set add 5 to make adder 5, right? So this is just setting the parameter a in this function that we've defined. And now what I can do is I can say print add 5 to 6, and I can print add 5 to 1 and to 3, and do all of this. And there we go. We run, we get 11, we get 6, we get 8. Now that's wonderful. So now we've got this first argument bound because it's up here in parameter a, and it doesn't matter when we end up calling this inner function, this a value is always going to be set to 5 because we've defined it as part of this make adder. So this seems a little bit dumb. Let's try and clean this up because I don't like having these 3 lines of printing stuff out, and I don't like having to type all of this add 5 stuff. So let's go ahead and instead say I'm going to set values to a list of 6 and 1 and 3. All right. Now what I want is the result of applying add 5 to those. So I could say add 5 to values 1 or values 0, and then add 5 to values 1 and 2. But instead, I'm just going to say I want to apply it to the entire list. How can I do that? Instead, what I want to do is I want to say set results. Let's see, set results to, I basically want to map those starting values to the result of applying them to that add 5 function. So I'm just going to assume that we have something called map. I'm going to say map values to the add 5 delegate. Now, of course, we've got to write that, but we'll go ahead and say print results at the end of that. So we're starting off with this list, and I just say for everything in here, I don't want to have to worry about figuring out how many things there are. I don't want to worry about having to specify the indexes. I just want to say do this for all of the things and get me the return value. So let's think about how we can write this function. Map is a function, and it takes a parameter of values, and it also takes some parameter that's a transform operation, right? And this has got to be some sort of function delegate. And we know that basically what we want to do, we'll create a list called results. So we'll say local results is an empty list, and then we'll just say for value in all of the values. Let's see, what do we want to do? We want to take the value. So we're going through each item in the loop, and we want to call transform operation using that as the argument. But of course, it's not just enough to run it. We actually want to get the value back. So we're going to say results add, and we'll pass in the result of calling this argument. And then finally down here, we'll return the results. All right, so this is just a mapping of some starting values based on some transformation that we want to do. So let's go ahead and run this and see if I have made some typos. And no, I have not. Look at that. We've got our list of 3 items. The first one is 11, the second one is 6, and the last one is 8. And now this map function, we could actually apply this to other stuff. So I'm going to go ahead and let's say we want to, let's create a different function called add hello, just for fun. We'll take a parameter a, and we'll return a plus the string hello. It's not particularly useful, but we can go down here and now we can say instead of applying add 5, I want you to call add hello on every element of my list. And if I go ahead and run this, here we go, 6 hello, 1 hello, 3 hello, the starting values plus the string hello. So now when I'm worrying about this, I don't have to care that it's a list of any particular length. I'm just saying, here's the thing that I want you to do to transform all of these values. And in fact, we can clean this map function up a little bit. We can, since it's a single line, we can go ahead and do that. We can probably put this up here since it's just declaring a starting value. We've got this wonderful little map function. Now there's one other thing that I don't particularly like, and that is when we're printing things out, we're printing out a list and it's got that list with the indexes. I don't necessarily want that. I want it to look like what it looked like before. So instead what I want to do is I'm going to say each, and I'm going to say for each of the results, actually we'll put it down here, each results, And here's something that's really cool. I'm going to say print, but I'm not going to say print. I'm going to say print @. Because even the functions that are part of the language can also be referenced as delegates. So now I'm just going to say for each of the elements in the results, go ahead and print them out. Now, of course, I've got to write that each function, but this is even simpler because this time we don't need the results. So I'm just going to say parameter values, and I'm just going to say operation because we're not transforming anything. We're going to take in two parameters, and I'm just going to say for value in values, then apply the operation to that single value. It's a very short, lovely little function. We'll go ahead and run that. And there we go. We get the three values because it's going ahead and calling print for every single item in that list. So okay, I've cleaned out this file and just left us with these functions map and each. We've talked now about how delegates work, but let's see some of the cool things that we can do with them. Now, functions like map and each are really useful because we can use them for a variety of different things. Let's say instead of trying to transform numbers, we have a list of parts. We want to just take the list of parts on our ship and I want to get what the name is of those parts. Well, I can use that map function. I can just write a function that takes in a single part and returns back the name of that part, and then I can just apply that map to a list of parts, or I could change it to any number of other things. But there's one thing that I think is a little bit frustrating, and that is this word map, because as wonderful as that is, okay, selection, as wonderful as that is, maybe the keyword map, if we use the word map in a library, there's a possibility that we could run into naming collisions in the future. Maybe someone else is using the word map to refer to some sort of map of Kerbin. Maybe the map just has a list of geo-coordinates or something like that. And all of a sudden, because we're both trying to use the same word, that we run into issues if we try and make this a library. So let's grab this each function. I'm just going to go ahead and paste that up here and then uncomment it out. And there we go. And of course, we've got the way that we can use it. We can say each list 1, 2, 3, and I'm going to go ahead and use the print delegate. So it's going to do that for all of these. And we go ahead and run that, and it does what we expect it to do. It prints out all of those items. Now, one of the ways, though, that we can actually hide this each is by putting it within a block, denoted by these curly braces. Now, of course, we've defined each already, so I'm going to go ahead and say unset each, because we're not rebooting the kOS craft between running these examples. So I'm just going to go ahead and hide that real quick. Let's go ahead and run this now. And now we see that we get an error called undefined variable each. All right. Now, if we think about what this is doing, when we define things inside these blocks, whatever we define is only available inside the block. It's scoped to this container. So if I go ahead and move this line up into the block and go ahead and run it again, then all of a sudden everything works. So now what we've been able to do is we could say, okay, I'm going to define this function, or I could set variables. I could say local foo is 5 or anything like that. But if I try and print out foo here, it's not going to work. Everything is scoped to that particular context. Now, one of the things the delegates provide us is a way to actually get functions out of this inner sort of hidden context. So let me tell you what I mean. I'm going to go ahead and create a local enum. I'm going to create this library that contains our map and our each function. I'm going to say local enum is a lexicon. And remember, a lexicon is just a set of key and value pairs. And I can get rid of this foo here, and I can we'll plop that down there for now. I'm going to say enum, that's actually set enum each to the each delegate. Now, what I'm doing is I'm defining this enum, and then I'm setting the key of each to that delegate. And actually, I'm not going to say local. I'm going to say global enum is lexicon. And now down here, when I try and call it, I can call it like this. I can go ahead and get this back out. Let's go ahead and run that. Okay, well, it didn't flicker, but it did the same thing. Otherwise, we would have seen an error. And now if I try and call each, That's still not going to work because each doesn't exist outside in that global context, but we still have access to it within this particular lexicon, which we've declared to be global. And in fact, we can do this in an even cleaner way because of some of the new syntax for declaring lexicons. So I'm going to say global enum is lexicon, and I can actually define this in line. I'm going to just go ahead and give it a key of each, and I'm going to give it the delegate of each. And there we go. Now I can clean this up and get rid of this. And if I remove this line here, we go ahead and run, and we get our 1, 2, 3. Now we can do the same thing now for this function map. Let's go ahead and delete that and paste that down in here. Get rid of this and indent these. And all I have to do is add it to our global enum. I'm going to say map is the map delegate. And you can just put commas. The way that this new syntax for declaring lexicons work is you declare the key name, and then you declare the value associated with that. Then you declare the key name, you declare the value associated with that as well. And now what we have is we have the ability to write libraries that have all of these internal functions that don't end up polluting the namespace, so that if you're trying to use them with your programs, you don't have to worry, oh, should I use that word? Maybe that word is already part of a library. You can just say, we are going to keep everything in our library hidden within these two braces, and that the only thing that we're going to expose is whatever we declare with global. And because we wrap it up in a lexicon, we can actually expose all of these things and let people just access it that way. Alrighty, so here we are looking at the documentation for libenum, and I'll put a link in the description in case it'll be released when version 0.19 comes out, but that may not be live by the time that this video goes up, so I'll go ahead and make sure to update the description. But you can see that there's an example here of run libenum, which is just running the file that has this enumerable that uses the same strategy that we just did manually. And we've got an example here, enum max, that takes a list and is going to return the largest value. And you can see it down here, there's a description of all of the various abilities that are encapsulated within here. So we've got all, which is going to test if everything in the list matches a particular function delegate. So you'd pass it a function that returns true or false based on an individual value. There's any, there's count, you count the number of things that pass. We've got each, which we wrote. We've got map down here, which we wrote. We've got find, which is just going to get the first part of the list, the first element in the list that matches a condition. Min and max, reject and select, which are nice. You can go ahead and say, here is a function that takes in something and returns true or false, and I'm just going to get the part of the list for which that returns true. So if I say I only want parts that have a fuel component, then I can take the list of all of the parts and I can say select, and then pass it a function that just checks and sees if it has if it has fuel. And then finally, there's a version of sort as well. And this all exists within the single enum lexicon, because we've got that all hidden. It's all inside its own block. And now we don't have to worry about, well, what if someone else uses the word max in part of their program? Then they're going to run into issues with using a library, or they use each or map or anything else like that. Because all of this stuff is here, we've got this all wrapped up in its own little module. And this is really where the power of delegates starts to really shine. Now, there's one last thing that I want to showcase about delegates, and that is that if we have a function foo in here, when it runs, it's going to run within the context. It's going to remember, even if we call it somehow outside of this block, it's going to run as though it were inside of this block. So if we have a variable here, we say local, name is Kevin. Got that. We can go ahead and say print name. And then let's see, if we have some global export is a lexicon that's going to get our foo out of here. I'm going to say foo and the foo delegate. Well, if I go ahead and try and run export foo, and I'll put the parentheses on there to say I'm going to go ahead and call that. Now, there is no name here. I'll go ahead and print name just to verify. There's no name outside of these blocks, but because foo runs inside those blocks, it still has access to it. So if we go ahead and run that, see, first off, it prints Kevin because it's running that function, but if we try and print name ourselves, then we don't have it. So what we've actually created here is we've created a private variable. this is only available to that foo function, and it's not available to us. And in fact, the only way that we can see what this is by calling that foo function. So let's do a little bit of playing around with this idea. I'm going to go ahead and say global Kerbal is a lexicon. We're just going to create something called Kerbal that we're going to go ahead and export. And what we can do is I'm going to say Kerbal.new Jebediah, and let's see, let's give him an age. Let's say that he's 12. I'm just going to pass in those arguments. We're just going to assume that we're going to write that. Well, that means, well, sorry, not .new. It's a lexicon. We're going to call it like this. And I'm going to say set Jeb to Kerbal new Jebediah and 12. Now that means that we need a function called new, and a function called new. In fact, I don't even need to call it new. I can call it, let's see, create. I'm going to call it create just for fun. And it's going to take in two parameters. It's going to take in a name, and it's going to take in an age. And now this lexicon has to expose that. It's got to expose new, and it's going to assign that create delegate to the keyword new. So these don't necessarily have to match. I can use a name that may be more helpful in here and then expose what it should look like publicly for someone who's using that library, because maybe I want it to be new, but maybe it's more helpful for me to call it create internally. Now, of course, it should probably do something, right? So what I'm going to go ahead and have it do is I'm going to, inside this create function, we're actually going to build up a representation of a Kerbal. So I'm going to say is local this is another lexicon, and we're just going to return this. So this is just going to represent the Kerbal that we've currently created. Now there are a couple things that I want to go ahead and set up real quickly here. I want our Kerbal to have some functions like print name. And that's going to have some delegates, so we'll call it print name. And I'm going to say print age. And that's going to have a delegate. We'll say print age. Now, of course, we've got to define these. So I'm going to say function print name. And all that has to do is print the name. And it has access to it because it's in that same level of scope. Now, the global Kerbal doesn't have that same level of scope. We're nesting too deep now. We can go ahead and say function print age. And I can go ahead and say print age. Do the same thing there. So now what this constructor function is doing is it's calling the create function, which is going to take in those arguments, and then it's going to save them inside this scope, and then it's going to return a new lexicon that has these functions available on it. So now if we go down here and I say Jeb print name, and we go ahead and run that, there we go. Jebediah has his own name, and he's able to print it. And because everything is sort of hidden inside these scopes, and these scopes exist when we call the create function, and not before, we can create a new one. So we'll call Bill. Kerbal new, and Bill. And let's say Bill is 10 years old, right? And we can say Bill print name. And if we go ahead and run that, there we go. We've got Jebediah and Bill. Now these are both using the keyword name internal to our class here. But because these are separate scopes, they only exist when we call the function, they remain there, and these inner functions persist these variables so that no matter where they exist elsewhere in the program, they're always going to be available so that we can call them. And in fact, here's something that's even cooler that we can do. Let's go ahead and say function grow old. And I'm going to say the body of that is to set age to age plus 1. Now what we can do is we can say Jeb grow old, and we'll call that. And we can go ahead and do that multiple times. And let's say, well, actually, let's first off have Jeb print out his age. Print age. And then we'll have him grow old 3 times, and we'll print age again. Whoops. Print age. Oh, I have pring age in here. Go ahead and fix that up. We go ahead and run. Grow old, what? Given key was not grow old. Do I not have grow old? Oh, I didn't expose grow old. There we go. Well, that is, yeah. Go ahead and add that in, grow old. And grow old delegate. Go ahead and run this. And there we go. We have Jebediah, who has his internal name and age that he can go ahead and save and store and keep private from us. We can't get that age directly. We can only have it print out the age, but we can also, by calling this grow old function, allow it to update its internal state. So ultimately, this is the real power of delegates. Not just that we can pass functions around as arguments and return values from other functions, but that we can use them to create scope, to create little bits of data about a bit of code that will exist alongside these functions. And that because we've got this function print name that relies on name and it's eternally bound to this create, that when we create a Kerbal, it is going to go ahead and maintain that indefinitely. We can create functions that modify it internally, but it'll always be the case. Now we have the ability to create our own objects, and in fact, we can set up different mechanisms for using inheritance, which is a bit more of the traditional programming type of route, but this is going to be a really big game changer, so I really wanted to kind of do a deep dive and talk about how cool function delegates are and some of the ways that they can be used. So let me know what you think. I'm looking forward to seeing what everybody's able to write with this new utility. Thanks a huge amount to the kOS devs for all of their hard work, and I will talk to you soon. Cheers.